Hey, what's going on, guys? So, Mr. Flores here with the next video that I'm going to deal with graphing. So, what I kind of want to do is just go over um, the graphs we use and a little bit about them. Right? So, the fancy name for them is called a Cartesian plane. All right? And we both know that the horizontal axis is known as our x-axis, and the vertical axis is known as our y-axis. All right? And when you have a full Cartesian plane, there's four quadrants. All right. So there's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right. These are the four quadrants, and they go counterclockwise. No matter what math you're in, whether you're in Algebra 1, Algebra 2, Pre-Calc, Geometry, these are the four quadrants. All right. They're not ever going to change. This is what they are, and this is how they are written. Right. Other than that, there's really not much to a Cartesian plane. I mean, you know that in quadrant 1, x is positive, and y is also positive. In quadrant 2, your x is negative, and your y is positive. In quadrant 3, they're both going to be negative. And then in quadrant 4, your x is positive, but your y is going to be negative. All right, and the only other last thing we really want to talk about is this point right here in the middle. All right, this stands for the coordinate 0, 0. Otherwise, it's known as our origin. All right, that's where our graphs always start. Whenever we graph lines, especially in slope-intercept form, you always kind of want to start at your origin because that's where everything starts. Okay. So let's just start off with a just an equation. Let's say we have 3x plus 2y equals let's say 7. Okay. So we have 3x plus 2y equals 7. Now, what we want to do is we want to find a solution to this scenario, okay? And basically what I mean by solution is we want an x and a y value that satisfies this equation, okay? So let's just say I give you the solution 1, comma 2, all right? Really, the question here is we want to check to see if 1, 2 is a solution to 3x plus 2y equals 7. Okay? If it is a solution, when we substitute 1 in for x, 2 in for y, our left side is going to equal 7. Right? Because that will satisfy our equation. So we have 3 times 1 plus 2 times 2 is equal to 7. All right. Now what we gotta do is just simplify. 3 times 1 is 3, plus 2 times 2 is 4, is equal to 7. So 7 equals 7, and we're good. So the correct answer would be yes. 1, 2 is a solution to the graph 3x, or the equation 3x plus 2y equals 7. All right, so let's leave this problem. So we have our friend Jay, and he starts out with having $2. Every day he makes $3 at work. Okay, so we're going to use a table to kind of figure out how much money Jay is going to have a little bit down the road. Okay, so let's say that x is going to stand for the number of days, and y is the amount of money he has. Okay, so basically we're going to have a little XY table here to tell us how much money Jay is going to have and X number of days. So for instance, let's say that at day 0, if you notice, it said Jay started with $2. So that means that his starting value, where X is 0, is 2. So our initial number here is 2. All right. Then every day Jay is going to be making $3. So if at 0 days he had $2, at 1 day he's going to have $5. Because if he starts with 2, he makes $3 in a day. 2 plus 3 is 5. Okay. Then we can say on day 2 he's going to have 8. Day 3 he'll have 11. And day 4 he's going to have 14. Okay. Because every time it went up $3. Because that is his change per day. Okay. Next class, or in a couple classes, we're going to learn a little bit more about what this means. But for now, we're just going to call this the change. Okay. So his initial value was a 2. His change was a 3. Okay. So now if we look, really what we have here, okay, we have a bunch of coordinates. So really our first coordinate is 0, 2. Okay, because that's where he started, 0, 2, because he started with $2. Then at 1 day, he went up to having $5. At 2 days, he had $8. Okay, and at 3 days, he had $11, which you can't see because it's off the graph, but that's the amount of money he had in X number of days. Okay, and if you kept going, if we had a higher Y, we could plot 14 and so on and so forth. So what I'm going to do here is I'm just going to plot our line. Okay, I'm going to put, oops, that's not what I want to do. All right, so we're going to plot our line. Like that. Okay, so, and there's our line plotted to match this table. Okay, because one of the things that you're going to have to be able to do is you're going to want to be able to be given a table, okay, and you want to be able to graph it on a coordinate plane. So let's just do another one like that. So here we're going to have our graph. Okay, we are going to make our table. X, Y. All right, let's start at 0, 1, 2, 3. All right, so at 0, let's be at -2. At 1, let's be at 2. So right off the bat, since we want to make a line, and lines have a constant change, okay, to go from -2 to +2, we know that that is a change of 4. So every single time we go up 1 to the X, we must go up 4 for the Y. So 2 plus 4 is 6. 6 plus 4 is 10. Okay, so our 4 points are going to be, there's going to be 1. And then at 1 we're at 2. At 2 we're at 6. Okay, and then 3 we're up at 10. So again, we're just going to make our line. All right, so we're going to go there. Actually, I want it to be red. So we're going to draw our line. Going to extend it. And that's going to be our line that follows this table. Okay, because that's one of the ways we can graph before we really know how to graph equations, by graphing tables. Okay, but the one thing you got to remember is that this table, we're going to be able to turn this into an equation somehow. And the two ways we're going to do that is, well, the one very important number is this change, okay? Because if you notice, every time the X increases by 1, the Y increases by 4. The other number we really care about is our initial number, okay? And that, again, is the number that we start at. So, for instance, if we go back to Jay's example, at 0 days, no, let's go back to that. At 0 days, he had $2. So the initial is where X is 0 and Y is 2. Okay. So really, when we talk about an initial value, we're really talking about when X is equal to 0, which is, as we're going to learn in later sections, a very, very important piece of data for graphing lines. All right, what I want you guys to do now is pause the video because this is the end. But before when you're done with the video, I want you to finish this problem where our friend Bob starts with 10 pieces of chicken. Every day he eats 2. Okay, and I want you to be able to fill in the rest of this chart. Okay, I want you to find the starting number and the change over the course of the whole thing. And then also what I'd like you to do is graph the line on a piece of graph, okay, or on a piece of graph paper. If you need paper, let me know. All right, hope you had fun. Hope you enjoyed it. Again, this is how we plot points in a line, and this is our precursor to how we're going to graph equations.